Look at that, dendritic gold floating on the surface. Is that cool or what? Hello scrappers, Mike here. Welcome back to my channel. So what do we got going on today? We've got two beakers up here on the workbench, and these beakers contain the remains from a previous video I put out. Not too long ago I put out a video of processing all the tens of thousands of tiny relay contacts my friend Johnny brought me from Finland. They were mostly silver, but there was some other stuff in there too. If you haven't seen that video, I'll put a link to it in the upper right. You can check it out. But anyway, what do we got here? We got the stuff that would not dissolve. I dissolved all those contacts in nitric acid to recover the silver from them. There's close to 4 pounds of silver there. But there's stuff that would not dissolve. And there was also some precipitates that were created along the way. So after dissolving those contacts in nitric acid, naturally I had to filter it. So that's what these filters are. And then there were some contacts that would not, can you hear that? That would not dissolve in nitric acid. They would not dissolve in dilute nitric acid, and they would not dissolve in concentrated nitric acid. So we got something besides silver here. I can see there's plainly some gold there, but I think we got some other stuff too. I'll give you a close-up look at what's here. So here's a close-up look at the stuff I'm going to process today. Here's all the little relay contacts that would not dissolve in nitric acid. Some of them clearly look like gold. And of course, you know, gold is reasonably pure, will not dissolve in nitric acid. Some of them are shiny silver though. So I'm thinking they could be platinum group metals, or they could be white gold. I'm not sure what we've got in here. Some of those contacts look like rose gold. So I don't know what in the wide world of sports we've got going on in this beaker. This other beaker, well, this has got all the filters in it from processing all those silver contacts. You know, I dissolved them in nitric acid and then filtered off all the debris, and the debris consists of gold to a large extent from the gold-plated contacts that were in there. So this is all that's left out of that 4 pounds of relay contacts that Johnny sent me. The rest of it's in silver. So let's see how much gold and if there's anything else we can get out of these before moving on. So yeah, so I want to try and process these today. Process these to try and get the gold out of them and see if there's any platinum group metals in there. There could be platinum, iridium, osmium, who knows what they made these contacts out of. The shiny silver ones anyway, or they might just be white gold, who knows. And then there's a fair amount of gold trapped in these filters too, because every stage of the filtration, as you can see, I've captured a fair amount of gold. So I'm going to try and do both of these processes in parallel and see how far we get and see what we get out of it. Okay, so let me get set up and we'll get started. Okay, I think the first thing I want to do is just move these contacts out of the way so I don't spill them and have them run all over the place, because I'll never collect them all again. And then we're going to process. We're going to start processing the filters. All right. So the first thing I'm going to do is I've got a brand spanking new graphite crucible here, and we're going to put the filters into the crucible, hopefully without spilling the gold they contain. Get them all in here. I'm going to have to wipe that out and put the rag I used to wipe it in here too. Bit of a wet piece of paper towel here and wipe the last little bit of debris because the debris contains gold. Get it out of this beaker. That looks pretty good. Get it all in this crucible. All right, we're going to take this crucible and we're going to put it in my compelling furnace, and we're going to heat it up, and we're going to burn off all that paper. And we'll just be left behind all of the gold and whatever other inorganic stuff we've captured. It should be a lot smaller volume. Hopefully the carbon will all burn off. We won't have a lot of carbon to deal with. So let me take it over to the compelling furnace and we'll get it cooking. All right, so here's my home-built compelling furnace. I have a whole series of videos on how I built this. I built it myself, every bit of it, furnace and the controller. You want one? You can build one too. Just follow how I did it. So let me get her opened up here. And we're going to put this inside. It's cold right now. Put this inside. I'm going to leave the door cracked a little bit so oxygen can get in and smoke can get out. I'm going to turn it on. So right now it's set for 600 degrees C, which is from a project I did before. But I think I'm going to leave it. That's probably higher than I need to burn off a paper in there. But that's okay. It'll give me a good burn off. And since I'm leaving the door open a little bit, you know, it's probably not going to get all the way up to temperature anyway. So as you can see, the temperature is slowly climbing up. It heats up pretty quick. 61, 62, 63. Remember, this is C now. So 65. So it's going to get really hot. It shouldn't be too long before we see smoke coming out of this thing. So let's go back over to the lab and start dealing with all those little contacts and figure out how we're going to deal with them. Okay, so how are we going to deal with these things? Well, for this, I think we're going to have to get some advice from C.M. Hoke. Her book, The Bible, on processing precious metal wastes. If you don't have a copy of her book, I highly recommend you get one. There'll be a link in the video description down below to where you can get one if you like. So the main problem we have here that we're going to need Hoke's help with, I think, is that we've probably got a mixture, or at least possibly have a mixture, maybe not probably, of gold and platinum group metals. And what I'd like to do is separate them. All right, I don't want, you know, my gold contaminated with a lot of platinum or iridium or osmium or whatever might be in here. On the other hand, I would like to keep them separate from the gold too. So how could we do that? So Hoke talks about how the different precious metals behave with aqua regia. And she says that gold will dissolve in cold aqua regia. But you really need to boil the more resistant platinum and other platinum group metals in aqua regia to get them to even partially dissolve. So I'm thinking then, if I just put some cold, or at least room temperature aqua regia, I mean summer in Florida, it's not going to be super cold. But, you know, ambient temperature aqua regia on this, hopefully it will preferentially dissolve the gold and leave behind any platinum group metals that are there. So I think that's what we're going to do. I think we put this in the fume hood, mix up some aqua regia, and we're going to do it according to the old formula, the 70-30 formula for aqua regia. And get it on here and let it sit and see what happens. The gold, and there's clearly gold in there, I can see it, should go into solution. And once it looks like the last of the gold's in solution, if I decant off the liquid, we should leave behind the vast bulk of any platinum group metals that are there. If they're there. I don't know if they're there or not. You know, stuff might be white gold, for all I know. My aqua regia may turn crazy colors from, you know, having nickel and whatnot in it. I don't know. We'll see. It should be enlightening anyway. So let's get started. Let me get this in the fume hood and we'll mix up some 70-30 aqua regia and see what happens. So I'm not going to mix up a lot. I've got this tiny little beaker here. It's only marked up to 80, but we'll just guesstimate up to 100, okay? I've got a little bit of nitric acid left, my store-bought nitric acid. I use 2 liters of this, almost 2 liters of this, and all of my homemade nitric acid I had on hand for dissolving those relay contacts. Now, I have ordered more nitric acid, but it has not arrived yet. But there should be enough here for what I want to do today. So let's start with some uriatic acid. Let's put about 70 milliliters of it in here. It's actually a bit much. Alright, that's right about at 70. And then we will just sort of guesstimate where the 100 milliliters is on this thing with nitric acid. There. I'm calling that 100 milliliters of Aqua Regia right there. So let me put that on the stuff in the fume hood and we will see what happens. Okay, so here's our contacts in the fume hood. Not on a hot plate, just sitting on a Corningware dish. I'm going to put a little bit of this in to start with, just in case we get a horrible reaction, which we do not seem to be getting. Okay. We'll put the rest of this stuff in. Never hurts to be conservative. You never know when you're going to have a boil over if you're not careful. So, okay, let me find something to cover that with. All right, and we'll just let it go. I do see some bubbling. I don't know if that's showing up. We do have some bubbling going on in there. So we are getting a reaction, which we should be because there's gold in there, and I just put Aqua Regia on it. So we're following Hoke's instructions to the letter here. So, yeah, we're getting some pretty good bubbling. Okay, great. So I would say the gold is going into solution. We'll see how much of this stuff goes into solution and how much stays behind. That'll be interesting. Now, since we're not heating it, this is probably going to take a while. I imagine it might take hours, but it's definitely working. So we're just going to let it sit there and do its thing. And I think I smell smoke. So I better go check the compelling furnace. I thought I smelled smoke. The wind wafted it over my direction. Let's see, where are we? 442 degrees. That's C, remember? So it's getting pretty darn hot in there. It's probably going to take a while to burn off all that paper in there because some of it was still damp. So this may take a little while, but oh well. We may have to wait hours for the stuff in the fume hood, so no rush. So we're just going to let everything sit and do its thing for now. Well, it's only been maybe 15 minutes since I put the Aqua Regia on there. The reaction has accelerated dramatically. We've got a lot of foaming going on in there. We're generating a lot of orange fumes. Is that a good thing or a bad thing? I'm not sure. The color seems a little muddy to me. We may have some base metals going into solution, so maybe some of that is white gold. I don't know. I guess we'll just have to let it go and see what happens. I'll be able to do stannous chloride test on it too and see if there's any traces of platinum in it. Right now I'm just kind of worried it might foam over. It's looking like it's trying. I better keep an eye on it. Alright, so it seemed to me like the reaction was getting the beaker a little warm. So I've filled the Corningware dish with cool water to try and keep the reaction from getting too out of control. And I don't want it hot because the whole idea of this is that the cold Aqua Regia will dissolve the gold and nothing else. So hopefully that's what's happening. I guess we'll see here in a little while. Adding the water seems to have slowed the reaction down dramatically. It's cooled way down. So I still see fizzing and bubbling though, so there's still a reaction going on. It hasn't stopped. I'll let it go until it looks like it's stopped. Alright, it's probably been close to an hour. You can see there's still a reaction going on. And to my eye, the aqua regia is looking a little green. So we definitely got some base metals going into solution along with whatever gold is there. So yeah, but the reaction has slowed down a whole lot. Just gonna let it continue until it looks like it's done. Let's go check on the stuff we're ashing in the furnace. It's been about an hour. It should be pretty well ashed, I think. Alright, it's been a little over an hour. I suspect we're done in here. Now, full disclosure, I have stirred this a couple of times just to make sure everything got exposed to the air as it was ashing up. We're right at 600 degrees, which I'm surprised it came fully up to temperature with the door partly open, but it did. That is pretty well ashed right there. Turn this off. Still a little bit of black stuff in there, but it's pretty well ashed. Alright, that cooled down. We'll let that cool down, and then we'll deal with it. But it's way too hot to do anything with now. Let's go back and see what's going on in the fume hood. Alright, this is looking very close to being done. I'm still seeing the occasional bubble come up. There's a faint amount of orange-brown gas in there. You may not even be able to see it on the video, but still something going on. So I'm going to let this go for a while. This needs to cool off too, before I can do anything with it. So I'll just let this go and deal with them a little later. Alright, it's been a while longer, and the reaction seems to have died down, although we're still getting a little bit of fumage off of it. But I want to see what's going on in the bottom of this beaker, so I'm going to pour off the liquid here and rinse whatever's in the bottom. That is some seriously yellow-green aqua regia there. Huh. I have to give you a look at that. I think there might have still been some silver in there, because we've got something that looks like maybe silver chloride. I don't know. Maybe it's something else. But boy, there is still a lot of very shiny metal in there that did not dissolve. Okay, I'll give you a quick look at that. Close up. There we go. That's the metal that didn't dissolve. Some of this white stuff away from it, which probably, I don't know if it's silver chloride or not, because it's awfully coarse. Silver chloride usually is very fine. I don't know what that is. And I don't know what that is either. The aqua regia didn't do anything to it. I mean, we dissolved something. The gold's all gone. At least, looks like it's gone for the most part. Yeah. I don't really see any gold in there. Some of those are looking a little reddish, but I think it's more the lighting I'm using than anything. So, let me pour the rest of this liquid off and wash these up a little bit. So, see if we can wash this stuff off the metal here. I'll filter this liquid naturally, where I try to drop the gold out of it. Get a little sloppy here. Some of this yellow liquid on the desktop. I'll have to wipe that up and keep the rag. Okay. I want to do a stannous chloride test on that too. take these out in the sunlight where you can actually see them in natural light. See that they are either dark gray or shiny silver for the most part. Now, don't know what they are. But since they didn't dissolve in aqua regia, I'm thinking platinum group. Not very much here, but should be an interesting challenge to deal with. I like how they've got sort of a peacock color to some of them. See that? Peacock feather colors. I'll do a little research and see which of the platinum group metals kind of does it. I know palladium does, but palladium would have dissolved in the nitric acid alone or in the aqua regia, so that's not palladium. There's something else going on here. All right. Very interesting. Okay, I want to do stannous chloride test on this stuff. So I know there's gold in it. So the gold signal may be dark enough to mask anything else. So we'll try this a couple of different ways and see what we get. Oh yeah, well, yeah, there you go. It's just black with gold. Absolutely black. So that's not going to tell me anything, but there's gold there. Well, now that's interesting. The gold just disappeared. So that's weird that the gold would just disappear like that. Put a little bit more of this on it. I got a thought. Yeah, I think I know what the problem is. I think. I don't know. This is a new one on me. Let me know in the comments if you've ever seen this before. Yeah, it's going away. There's bubbling too as it's happening. That is interesting. All right, so let's try with a piece of filter paper. See what we get. Yes, we get gold. Got some orange up there too. I don't know if that's showing up. But zoomed in about as far as I can be. Hopefully it's in focus. Got a little bit of orange up there. I'm thinking platinum. So we got trace of platinum in here. Okay. Trace of platinum, probably some silver chloride. And I don't know what kind of crazy chemistry is causing that. Let's see here. I'd say silver chloride. Yeah, that's what I'm thinking. Okay, so I'm thinking also if I dilute this with a lot of water, we might get a lot of silver chloride crashing out of solution. There might have still been some silver in there. So that probably got dissolved by the aqua regia, and now it's going to come out of solution. Let me find my distilled water. We'll add some distilled water to it and see if stuff comes out of solution. We'll see if this goes all murky. Oh yeah. So yeah, I think silver chloride. Okay. All right, so gonna have to filter this to drop the gold out of it. And then what to do with these over here. For now, I may just put them on the back burner and concentrate on getting the gold out of here, and I've still got to do the filters. So what I might do is the filters next, and then combine the liquid from the filters with this liquid, and then we'll drop whatever gold out of it we can. I'll use a selective precipitating agent like ferrous sulfate. So hopefully we'll just get the gold and we'll leave any platinum group metals in solution. Hoping we will anyway. Yeah, we got a white precipitate settling on the bottom, so I'm thinking that's silver chloride. But I still don't know why this went yellow again. I have not seen that before. I mean, I can make it go black by adding more stannous chloride to it, but then over time, with some bubbling, the black starts disappearing and the yellow reemerges. Definitely leave a comment if you know what the heck is going on here, because I'm a little bit at a loss. Oh, you know what? I know what the problem is. Duh. I know what the problem is. I use way too much nitric acid. I used old school 70-30 nitric acid. That's what the problem is. The nitric acid's causing it. I'm going to have to denox this too before I do anything with it. So that's the problem. Never mind. I know what the issue is. So, okay. Got to denox that, filter it, and deal with the filters. So let me clean up the bench and get to work on all that. All right, let me get these ashes into a beaker so I can start processing them. Get every little bit. Ooh, I can already see gold in there. I'll give you a close-up look. But yeah, there was a lot of gold in those filter papers, so I'm not surprised to see gold right off in the beaker here. That's pretty good. Yeah, actually, I see a little bit more gold stuck to the side of the crucible. Get it all. All right. Yep, I'll give you a close-up look at that. Yep, there's gold in there. If I stir it up, there's a big chunk. There's a chunk over there. There's some up there. There's a lot of little pieces too. And there's a lot more under the debris. So let's get this in the fume hood and get some aqua regia on it and dissolve the gold out of this stuff. Then we can mix it with the aqua regia from the contacts and drop all the gold together. Okay, let me get the fume hood running. And we'll make some aqua regia here on these ashes. We'll start with some muriatic acid. There's not a lot of gold there, so we don't need a lot of liquid. Let me rinse the stuff down off the sides into there. Okay. Now, I don't have a whole lot of nitric acid left, just a little bit, but there should be more than enough here for this process. You get a few milliliters in a pipette. There's about 2 milliliters, which is probably more than enough to dissolve that gold, but I think there might be some base metals in there that are getting me some trouble, so I'm going to add about another milliliter and a half. Okay, let me cap it up and put a little bit of heat to it. We're not too worried about getting platinum group metals in solution now. So give it a little bit of heat, speed the process up. Hopefully get all that gold in there dissolved. All right, so we'll just let it do its thing for a while. So as for this very green aqua regia, I'm going to transfer it to a bigger beaker because there's not much space in here. Something floating on the surface, I'm not sure what. Doesn't look like gold though. Sometimes gold will come out of solution on its own with aqua regia. I'll get this yellow precipitate out of here too. I don't know. I'm not thinking it's silver chloride anymore. It's too coarse and the color's wrong. So I don't know what it is. Who the heck knows what was in those contacts? I suppose it's possible it could be one of the iron oxides. Anyway, now that I've got a bigger beaker, we're gonna denox this stuff. I'm gonna mix up a saturated solution of sulfamic acid, and we'll use that to denox this stuff before I filter it. Actually, you know what? Skip that. We're going to add the stuff in the fume hood to this, denox the whole thing, and then give it a filtration, and then drop the gold. Okay, so there's just fewer steps that way. Why repeat myself? So we'll do it that way. All right, it's been a few minutes, and yeah, we've got a reaction going on in there. We got some bubbling, we got some fume production. So, yeah, and that's just barely warmed up too. So, good stuff happening in that beaker. Gold going into solution, maybe some other stuff too, but we've already got dirty aqua regia over here. I don't think we're going to make it that much dirtier. So, uh-oh. I'm going to keep an eye on this. The reaction seems like it's really taking off. Turn the heat back off and keep an eye on it. Make sure it doesn't boil over. Alrighty, the reaction seems to be complete. Let's get a little bit of this stuff on spot plate and do a stannous chloride test on it. I have no doubt that we have gold in solution here, but we'll do a test anyway, just to be on the safe side. Alright, let's move over to the table over here. Alright, let me get you a good view of it here. I'll put a little bit of stannous chloride on it. Boom! Yeah, okay. We got gold in solution. Not that there was much doubt, but okay. So next I need to just mix these two solutions together, denox them, and filter them. So I'll do that in the fume hood. Alright, let's get these two solutions mixed together. It should contain all our gold. From the relay contacts. Alright. We'll get this denoxed and we'll filter it. Got my usual saturated solution of sulfamic acid here for denoxing. Oh yeah, excess nitric. But we knew there was excess nitric in there. So this will take care of it. Okay. I'm going to call that denoxed. Thoroughly denoxed. Alright, let me set up for filtration. We'll filter this and then we can drop the gold. Okay, let's get this goop filtered. Set up for vacuum filtration here. This should not take too long. As per usual, I'll make sure to get the liquid through first before the solids in the bottom of the beaker go in. Because once they go in, that'll slow down the filtration something awful. It's actually interesting that the color is not as bad as it was. It's much less green. But the yellow color can also be from iron. So it's possible we got some iron contamination. I know there's not that much gold here. At least I don't think there is. So, and remember, I think we got a little bit of platinum in solution. So I'm going to have to use a selective precipitating agent on this stuff. I'll have to mix up some iron sulfate or copperas to drop this gold. Because if I use SMB is a selective precipitate too, but I think iron sulfate is much more selective. I mean, it's really easy just to go for the bottle of SMB rather than mix up some iron sulfate, but I think I'm going to do it just to try and get as pure gold as possible. Okay, so let me get this filtered, and then we'll move on from there. All right, I got all the liquid through. It's nice and clear. Got to wash the yellow color out of the filter, and we can move forward. Okay, I have transferred our gold solution to a bigger beaker out of the vacuum beaker or vacuum flask. Here's some iron sulfate solution. Let's see if we can precipitate us some gold. Oh yeah, I would say we've got a good gold precipitation going on. You never know how much of this stuff to make, so I'm glad it looks like I've made enough. Oh wow, can you see the gold floating on the surface over there? I'll try and get a close-up of that with my phone. I do love precipitating gold with iron sulfate because you always get this dendritic gold floating on the surface. That's very cool. Wow, will you look at that? That is mesmerizing. That is way, way cool. Gonna be ashamed to make it sink, but I'm gonna have to hit it with my water bottle and make it sink so it can join all the other gold on the bottom of the beaker. But that is really cool, those dendritic patterns that form. That is way cool. So we'll wait for that to settle, and we'll see how much gold we got. I'm not expecting a huge amount, but you never know. Maybe there was more in those contacts than I thought. Well, hey, would you look at that? This is settling pretty well and pretty quick. Yeah, and what looks like a nice layer of gold on the bottom of this beaker. I'm going to let it settle a while longer, maybe overnight, and then tomorrow we'll decant off this green liquid, clean up that little bit of gold on the bottom, dry it out, and weigh it, and see how much gold we got from those relay contacts. This should be interesting. Stay tuned. Alrighty, so here's the gold on the bottom of this beaker after siphoning off almost all the liquid. Siphoned it straight into my temporary stock pot. There's more gold here than I was expecting. Of course, it always looks like a lot when it's wet. When it's dried out, maybe not so much. I'm going to transfer this to a much smaller beaker and start giving it some boils in distilled water in the fume hood to clean it up. And then we'll dry it out and we'll get a weight on it and see just how much this stuff weighs. And I have some news about these contacts here, which will not dissolve in nitric acid or aqua regia. I now know what they are. And they're tungsten. I didn't even think about tungsten. But yeah, that's what they are. They're tungsten. I was talking to my buddy Jim yesterday about some of the big chunky contacts that Johnny brought me that I still need to process. And Jim said, be careful, because I processed a bunch of those and they turned out to be tungsten, not silver. And I thought, tungsten. So I started doing a little bit of research, and yeah, tungsten oxidizes with those funky colors that you see there. So that's exactly what we've got here. We've got tungsten. It's very resistant to dissolving in nitric acid, and it oxidizes to these sort of peacock feather colors. So that's exactly what we've got, tungsten. It makes perfect sense. It's a very durable metal, has the highest melting point of any metal. So it'd be the perfect thing to make some contacts out of. They might have been silver plated originally, but yeah, that's what we got, tungsten. All right, so let me get to busy cleaning up this gold so we can get a weight on it and put that project to bed. All right, there's the first boil in distilled water. I'm going to give it at least 2 more, and then we'll dry it out and weigh it up. All right, it's time to find out just how much gold we got out of Johnny's 4 pounds of relay contacts. Let's see, we are on the gram scale. Now this is all dried up, and it still looks like a whole lot. Usually when gold dries up, it doesn't look like diddly squat. But this still looks like a whole lot. Ooh, we're already above 2 grams, so I guess it is a lot. 6 grams. Holy cow, I'm going to need a bigger weigh boat here. Stay in there. Johnny, those relay contacts alone, the gold in them was worth the price of admission, buddy. Plus, we're getting a whole lot of silver. A whole lot of silver. I haven't even started on the fully gold-plated ceramic ICs yet. Look at that, 11.61 grams of gold. That is a third of an ounce of gold, better than a third of an ounce, just from those relay contacts. I was going to put that in this little jar. I'm going to have to find a bigger container. That's a lot of gold. Holy cow. All right. Wow. That's amazing. I was not expecting that. I really did not think there was that much gold there in those contacts, but apparently there was. Some of them must have been solid gold, Johnny. A lot of them look plated, but some of them must have been solid because there's too much gold here for plating. Woo! Well, I'll bet you're happy about that. I'm happy about it. Hey, if you guys out there in the audience are happy, give this video a like, give it a thumbs up, and subscribe to see future videos. I got a lot more Johnny's stuff to refine. And we're going to get a lot more gold and more silver in the future. So subscribe to see those future videos, and I'll see you in the next video. Thanks a lot for watching this one. Bye.